So Bob Foreman is here to join us with our ECL tip, and he's talking all about the ECL sets. So Bob, over to you for our training tip.
Thank you, Jessica. Hello out there, HPCC and ECL lovers, everyone in the United States, the UK, maybe Brazil, India, China, and all ships at sea. Welcome. Glad you're here. And this month's tech tip, you know, I think of my job and I think of just what a blessing it is to be working for a company where you're just surrounded by such cool technology with Adwait's presentation and Jan Rui's presentation. I think of this tech talk as like a big 3-course meal. Like Adwait's presentation was kind of like the scallops wrapped in bacon. And then, of course, Jan Rui's presentation was like the filet mignon. And, here comes the cheesecake, all right? So we're going to be talking all about the ECL set. And my first poll question for you is just a little review. Some of you who have been in class with me or taking the online lessons may know this question. Let's see how many people can get it right. Which of the following is not one of the 4 fundamental types of ECL definitions? All right, so while you're thinking about that and answering that question, let's move on and talk about one of the ECL definitions called the ECL set. Now, when I first encountered this, I thought of a set kind of like the new math type of set, and then, well, it's quite different. It's more of a set of individual constant values or expressions, and where it departs from that new math type of set, new math sets were kind of mutually exclusive, where in our ECL sets you can have duplicate values, for example, and the only rule is that all the elements must be of the same type. So here we have several examples of what I like to call static sets, or in the ECL language reference manual, they call them constant sets. And we have true or false values, 0, 1, which is an integer. We have a set of strings here. And it's kind of confusing a little bit sometimes. People look at that and they think, well, the strings have to be constant length. Absolutely not. So you could put in these elements Florida, Georgia, South Carolina with space, and everything else. So the status codes, the set of integers that you see down here, referencing definitions that aren't shown on the slide, but those definitions better evaluate to an integer or else the compiler will complain. So that's how you define a set. You define a set with, of course, the definition operator followed by the square brackets, and then each individual element is separated by commas. Most of us know this. The workhorse of the expressions used with sets is the in operator. And the in operator simply says, is this value, is this field in this set of values? And so, for example, at the bottom here, we have a set of Southeast states. We have an ECL function, which is passing a parameter, a two-character string state. And we're simply testing then, is that state in the set of Southeast states? So if it's either Florida, Georgia, Alabama, or South Carolina, the function will return a true. Otherwise, it will return a false. All right. And then our second type of set, which I find very useful in a lot of different ways, is called a dynamic set. And this, we use the ECL set function. The set function has as the first parameter the record set that you're reading, which can be a large data set of fields. And then you say, which field out of that data set or record set do I want to create a set from? So it will automatically create that set. Yes, that set may have duplicate elements in it based on the field values, and so on. So in this example shown here, we've got an inline data set A through J, and we simply have a set function that applies a filter that says the set of some file letters greater than C, and we're using the field letter, which was, in this case, the only field in this data set. And then when we look at the two Boolean expressions shown here, is A in the set of letters D through J? Well, obviously not. That's going to give us a false. And then the second one is D in the set of letters D through J. Well, of course, that's obviously going to give us a true. So far just a number of the basics here. And set is also a value type where, yes, you can specifically say what kind of a set of elements it's containing. So, for example, in this slide here, a set of closed codes, there are numbers. If you don't specify what type of numbers they are, it would automatically default to an 8-byte integer. So here we're kind of turning it down, paring it down, saying we have a set of 1-byte integers, anything from minus 27 to positive 128 would be in that range. And then we have a function here that's using this set that we've created up above, where we're passing the set in a function. So the word set can be used as a keyword as one of your function parameters. So very simple, this function just simply says, is the code you're passing in the set that you're passing? So then applied to the accounts record set, we call the function as our filter. And is that field account status as we're reading each account's record? If it's any one of these numbers above, 65, 66, 90, etc., then we're going to get the record. Otherwise, we're going to reject the record. All right. Sets can be also ordered. You can also index into sets. So here we have a set of 5 numbers, and we say, what is the 5th element of that set? And, of course, that's going to give us the number 1. Also, since sets can be indexed, another kind of side feature of ECL is all strings can be thought of as a set of characters. So every string that you deal with in ECL can be an implicit set. For example, here's my string being A, B, C, D, E, and you can then index into a string and say, all right, what is that 3rd character of that string? In this example here would be C at the top. So because we can index into strings, we don't really worry about a substring function in ECL because our string indexing can do exactly that. So for the first example, my string 2.4, the dot being an inclusive range, will return a B, C, and D. So starting at the 2nd character B up to D. And then again, 4 says start at the beginning of the string and give me up to the 4th character, including the 4th character, which is A, B, C, D. And then finally start at the 2nd character and go to the end of the string, which is really powerful in a lot of cases, B, C, D, E in this result. All right, so that's all the basics of set. And here, this slide right here is kind of the tip of the month. And I wanted to talk about this because new students and people that come into the advanced classes, a lot of times they'll see this and they'll say, no, I never knew that you could do this. So I wanted to kind of expose it a little bit and talk a little bit more about it, what you can actually do and how a set and a data set can kind of interact with each other. So, for example, here the first line that says set of all states is defined as we're using a dynamic set to create a set of states from a person's record set or data set. So we have all the states into our set of all states, and now I can just drop that into a data set statement and give it a record structure, inline record structure, in this case a string 2, which was the field that I was reading from the person's data set. And now the data set can actually, the set itself, all the individual elements of the set can now be treated as a data set. So everything you do with a data set, sorting, projecting, joining, everything that you do with data sets, you can now do with a set by just dropping it into an inline data set and redefining it. So here we take a data set, we sort it, we dedupe it, and then we give a count. So in this example, you might guess what we were trying to do here. We were trying to look at how many unique elements we had in our person's record set, how many unique states that we have. Another thing I saw as I was going through these slides was that also the count function can also count a set directly. And it's not really specifically stated in the documentation, but you can do a count of a record set. You can do a count of a comma delimited list. And so you can do a count of a set because a set really is a comma delimited list that's enclosed in square brackets. And it'll tell you how many elements you have in this particular set. All right, so that's the tip of the month. If you have any questions on that, feel free to email me. And but the cool thing is just the ability to drop any set into a data set and then work on those set of elements, sort them, dedupe them, project them, do whatever you like, and then eventually you can put them back into a set by using a set function. So, all right. So some of the other functions I ran into, since we're talking about set being the flavor of the month here, other functions that use set, and I wanted to bring these up because I don't see them used too much, and so maybe people don't know that they're there, or they don't have a need for it. But a set in its native form cannot be sorted directly. You can't use the sort statement on a set because a sort is looking for a record set, and so unless you just drop it into a data set. But sometimes you can do sorting of sets directly by using these two functions here. One is called rank and the other one is called ranked, which we're going to look at in the next slide. But this slide right here, rank, simply says, take that first element in the set and tell me, after this set is sorted, where would that element be? What position would that element be after it's sorted? And by the way, the default sort is ascending. So I want to know the first element, where it's going to be after the sort. And if you can look at this, you'd say, well, 20 is going to be the second element of the set after sorting. Using the descend attribute in the rank, you can say, well, let's do it the other way. Let's take the same set and say, well, here's rank number 1. Again, the first element being 20. Where will that be after the sort? 40, 30, 20, 10. The third element in the set. And as predicted, that's our result. So that's rank, and the opposite of rank is ranked. So you can also look at a given set, like for example, once again, 20, 30, 10, 40, and say, which one of these elements in this set will be number 1 after the sort? So once again, looking backwards, we say 20, 30, 10, 40. Well, obviously 10 will be the first element in the set after sorting, so the answer here will be 3. And in the descending mode, which one of these 4 elements will be the first element in the descending sort? And of course, it'll be 40, which will be the number 4. So rank will return a 4 in the second case, 3 in the first case. And then there's other functions that use set. We've got merge join. I wanted to include this because the first parameter says set, and it's a set of data sets. I don't know how many people out there have used merge join, but I think it's been probably around forever, and it has its uses. And I think it was more used for maybe doing things in Roxy and HTOR, because using this in Thor, it only defaults to local operation. If you try to run this code on Thor, you'll get a warning that says merge only operates in local operation in Thor. But here's how it works. You simply take a set of data sets, and in this case, in this slide, you see 3 data sets here, DS1, DS2, DS3. We're building a set of them called set DS, and then we're applying set DS to the merge join. So not only is it merging the 3 data sets together, but it's also merging them based on the join condition. I will say this right now. I had pulled this example directly from the language reference manual, and for the life of me, I don't really know why they're using stepped here, because stepped doesn't really do anything, at least in Thor. It had no changes to the results, or really not much in the performance. I think maybe it may have been used a while ago, but stepped is a special function that's used with indexes. So I really don't know why they were using this in the merge join, but if you take stepped out, it kind of works the same way. In this example here, we're looking for matching left letters and right letters, and what merge join will do then is it will actually look for common letters in all 3 data sets. So if you study the slide, you'll see that the only record in the data sets that have a matching letter in all 3 is the letter B. The only other thing that kind of I get a chuckle about is the attribute on merge join called MOFN. For the life of me, I was asking everybody what that meant, and nobody could tell me what it meant. Someone had created it some time ago, so I always have fun. Like, what could that be? Most often, but I think it was most of matches of the, now it's escaping my mind here. Matches on the value n, and the first parameter is the minimum matches that it will return, and the second number is the maximum matches that it will return. So anyway, that's the question for that one, is MOFN. I think I've got it documented somewhere, but see, even I forget after a while. And the last thing I want to show you is range. Range also works with sets of data sets. If you want to get a subset of a set of data sets, you can simply then treat each individual element of the data set as an element, and then you say, I only want to range on 1 and 3. So your first data set in the output of the range would be A, B, C, D, E, and the second data set in the range would be K, L, M, N, O. So these are just the many functions that are natively supported in ECL and supported with the set definition and using sets. One of the things I really didn't talk about, because I just dived right into this, is what do you use sets for? And the thing I tell any new student learning ECL is it really simplifies multiple OR conditions. I think that was probably its original design, was that if you had, for example, a filter of all of the Southeast states, I mean, you could write a filter and say state equals Florida, or state equals Georgia, or state equals Alabama, and you get what I mean. Your filter would become a nightmare if the elements start to increase. So sets help to eliminate the multiple OR conditions that you can have in a filter by just using the in operator with your set and saying field is in the set of values. And there's so much more. I've seen sets used in machine learning. They do a lot of things with simulating matrices and things like that. And you know, people a lot of times use sets out of the box for many things. And I mean, the big thing was, you know, being able to take a set, drop it into a data set, doing anything you want to do with it, and then actually restoring back to an original set if you need to do that. So that's my quick overview of sets and the tech tip of the month. And my last question, hopefully I'll get a good result on this one. Was there anything new that you learned in this month's ECL tech tip? So it's a softball question. Hopefully you learned a little something or saw a function that maybe you didn't know or didn't use, and maybe you'll try it down the road if you have a need for it. So I'm going to fast to my next slide here, and Jessica, I'll turn it back over to you.
Awesome. Thank you, Bob. You started us off with this wonderful lunchtime talk of like scallops and bacon and wonderful food, and we're just wondering what you've been eating lately, because, wow, Bob, that sounds great. And then you gave us this wonderful meal of ECL tips. So thank you.
That's the trick. That's the problem. I haven't been eating anything, so that's why I always have it on my mind.
Oh, see, we thought it was your lunchtime. There you go. So, all right, let's well, you look at the questions from the audience and prioritize your key ones. I'm going to get to your very first poll, and the question was, which of the following is not one of the 4 fundamental types of ECL definitions? So, Bob, you're going to have to help us with this, but we've got 40% said value, 40% said data set, and 20% said record set. What do you think?
Who said how many people said data set?
Well, I don't know how many, but 40%. That's all I get are percentages.
Let me see. Let me just check real quick. The answer is data set. That is not a Boolean definition. So 40% got it right. A value definition is a definition is like any value, like a string or an arithmetic value. And a record set is a valid definition. A data set is an ECL language statement that everyone knows that is defining the source of your data that you're going to be working with on the HPCC cluster. It is not a definition per se. It is a statement that locates your data on the cluster, or an inline data set being in memory. But the 4 fundamental definitions are set, value, Boolean, and record set.
Fantastic. Thank you so much, Bob. Are you ready for your questions?
Sure.
All right. So question number 1 is there any limitation to the length of a set?
All right. The answer to that is interesting. I think, people will also ask, is there any limitation to the size of the string? And I think it goes to the hardware boundaries. However, there is an issue with the set function where if you use the set function with an in operator, sometimes you may get a result that says data set is too large for the work unit. And I believe, Gavin Halliday has an issue tracking report on that. They're going to be addressing it, either improving the messaging of it so it doesn't crash or something that. But it is being addressed by the development team. That's the only limitation right now that I'm aware of. All right, next question.
All right, so our second question is, what is the most popular use of a set?
Okay, well, I think I kind of gave away that answer at the end of my talk where, primarily sets are great in filtering with multiple OR conditions where you are building a set, using it as a filter so that you greatly simplify your filter clause as you're filtering through a set of records.
All right, thank you. All right, so the last question that we have here is, does static set have an index? Well, I'll let you look at the question there, but such as
sure.
I in brackets 1 of set of integer I equals 1, 2, 3.
All right, so it looks like indexing can be done on any type of set, whether the element is a string or an integer or even a set of reals or whatnot. So yes, I mean, you can say I sub 1 and it will give you the first number of the set. In that case would be 1. But if you had your set of integers being 3, 2, 1 and you said I sub 1, it would return the first element of the set, which would be number 3. So it's not really a pointer, it's just an indexing into a set of elements, and whatever is returned is based on how you have the set defined, whether it's the whole rule of sets is that they all have to be the same value. You cannot mix integers with strings and strings with reals and so on. They all have to be the same value. Haha, I like the next question here.
All right.
Can you give an example to use rank and ranked in real applications? And I'm going to be honest with you. I searched our Alpharetta repository, Boca repository for anybody, any ECL developer that was using these functions. And here so goes the story of ECL. ECL has been around now for almost 20 years. And I will say that what started as a 32-page language reference is now well over 400 pages. I'm pretty sure that there was probably some need to do rank and ranked by somebody, and so it was created by the development team to allow them to do that very easily. But I haven't seen any recent use of it other than, like I said, the use of rank and ranked can tell you the sort value of an element of a set without sorting the set. So it kind of looks ahead and says, after this sort is after this set is sorted, what would be the first element of the set? What would be the second element of the set? You can reference any element and actually put that into a kind of a loop. But there's other ways of getting to that mountain if you needed to do that. But really, I haven't seen any practical application of anybody using ranked and ranked, and I'd like to see one, definitely.
All right, fantastic. So, Bob, we're going to take a quick peek at your last poll question, and you'll be very happy to know. You'll be really happy to know that it says, "Was there anything new that you learned in this month's ECL tip?" And 100% of people said yes. So we're thrilled to have that, and of course, that is why we have Bob join us. So thank you, Bob.
You're welcome. Thank you, everybody. I really appreciate it. And stay tuned for next month. We'll come up with something else that's pretty cool for you.